All right, welcome to Comp 110, everybody. Today we're going to be doing something special. We're going to be trying to get into our house Zooms. And before we get into content, I want to just give a little bit of direction here on what to expect and how to find your Zoom, and also how to navigate a day like today. We're not going to do every day like this, but we will have some days where we try and do some synchronous activities so that you get a chance to interact with your peers in the class, and we get a chance to interact with you as well and your TAs. So do please be wearing headphones when we are in breakout rooms. If you have your speakers on and your microphone picks up on me giving an instruction over YouTube while you're watching here, it'll confuse Zoom and it'll echo through everybody else's, and it's kind of annoying. So try to wear headphones for days where we're doing Zoom. And when we're in all together in the same Zoom, we're not doing breakouts, go ahead and have your cameras off. This will help save everybody's bandwidth. Some people's connections aren't quite as strong as others. So turning your cameras off will help. It also avoids distraction. But when we do go to breakout rooms, please have your cameras on. The way that you can find your house is through Sakai. So if you go to Sakai, you open up our course page and you find a tool called Postum. Postum is a tool that you'll see in the sidebar for our course. And that's a way that we can deliver specific information to you that applies to you only versus the class as the whole. And there you'll find a Zoom URL. The password for today's Zoom is comp110 ! I don't think you'll need it. I think it's embedded into the codes, but if for some reason Zoom is asking you for a password, it's comp110 ! And we also are requiring you to log in with UNC single sign-on. So be sure that you're logged in the correct way that we went through last time that we tried this, which is to, if you don't know, you can log out and then log back in using SSO. You enter UNC as the domain that you're trying to log into the single sign-on of. It'll take you to your Onion login. So there you'll log in with your UNC Onion and password, and then it'll bring you right back to Zoom and you'll be logged in. Logging in this way will actually enable more features for your Zoom than you would have on a personal account, because we have a university site license. It doesn't have the restrictions in meeting time length and some other things. So if you don't already have Zoom pulled up and you're not yet in your house Zoom, I would encourage you to join up. We're going to have just a couple more minutes. I've got one more announcement I want to make about your house TAs ahead of this. But go ahead and try and pull Zoom up and make that connection, and you can listen to this next announcement in the background if you're not already connected. So now everybody is assigned to a house, and each house has 2 TAs on the team that are dedicated to it. One of those TAs, or potentially more, will be on your Zoom call today, so you get a chance to meet one of your head TAs. Our Zoom calls today are actually made up of 2 houses, so that we have 10 Zooms going right now concurrently. Once we get comfortable knowing that we can manage that, we might go to 20 Zooms for each house to have its own individual Zoom. But one step at a time. We had enough problems the first time around. We don't want to get too far ahead of ourselves. So I want to talk about getting support and how to email for support. Please use office hours and course care for questions about programs, for errors that you might be seeing, anything that you might be inclined to take a screenshot of or try and attach some files to. Please come to office hours with those concerns. For technical support, for questions on exercises and projects when we start them, it's much more effective for us to work with you one-on-one in office hours than over email. And so typically if you try and email about these things, the expected response is, hey, I can't help with this over email because it would take an hour to work out sending emails back and forth. Just come see us in office hours the next time we're open. But if you have questions about the course, like there was something that was said in lecture that wasn't clear, or you had some confusion on when something was due, or something's come up, emailing your 2 house head TAs and CCing both is the encouraged way to interact and reach out outside of office hours and for things that don't involve technical support. Please be sure to carbon copy or CC both of your TAs. This is such a funny, CCing is such a funny term to me, because carbon copying is the idea of like when you write in a checkbook and you have that piece of carbon paper that makes the copy of it, and the fact that that name stuck around for emailing is always kind of funny to me. But please do CC both of your TAs. You can find them in the same place that you can find the Zooms, under Post 'em on Sakai. So you go to Sakai, go to the course site, look for the Post 'em tool, and then look for your house. And there will be a few fields there. It'll have the name of your TAs and their emails. And you should be receiving an introductory email from them in the next few days, if you haven't already, to get a sense of who it is that you'll be working with this semester as your lead support. Right? If for some reason you don't hear back from either of your TAs within 24 hours, forward that email to Comp 110 heads. That'll come to me and Kaki, and we'll look into it. But typically you can expect under 24-hour response time. It's typical that if you send an email after 9 o'clock at night, it's unlikely you'll get an email until the next morning. So don't wait until the deadline to reach out to us. Okay. I think what we're going to try and do now is move to our first Zoom for introduction. So in just a moment, I'm going to turn it over to the TAs and mute the YouTube stream. And if you're not yet connected and you want to connect, it's not too late. Again, the instructions are to go to Sakai, Post 'em, and then look for your house Zoom. Password is comp110!! And we're going to form breakout rooms of 3 to 4. I want you to go ahead and start thinking about how you're going to introduce yourself to some of your new housemates. Where are you from? Where are you currently right now? I know a lot of people are in transition. What's your intended graduation year? What are you majoring and minoring in? And what is one non-academic fun fact about you that is just a way to break the ice, all right? Once we get through these introductions, we'll have about 8 minutes to go through these introductions. Catch up on how people are doing. I know we're in a weird time right now, so get to know one another. We'll spend about 8 minutes on this, and TAs, you can go ahead and take it away. All right. Hopefully you were able to make some connections and get a sense that the people in your house have something in common with you. Largely, we tried to group folks by their prior programming experience, and then we tried to group folks by your year and majors. And so hopefully you got the sense that you're in Comp 110 with some people who are very much in the same position you are, or very close to it when it comes to experience, and we'll be able to rely on one another for helping navigate some interesting exercises throughout the semester, as well as I think in the end of the semester, we're going to be doing, hoping to do a pair project as our very last project optionally. And so relying on people in your house as contacts and getting to know others through these exercises is going to be great. We're going to have one more Zoom later in today's live lecture, but let's get into a little bit of new content first. And what I should mention is if you are joining just now, or you are catching up on this asynchronously, don't worry today. We were mostly trying to do a proof of concept today. Be sure we've got our tech in order and a means for communicating this. Behind the scenes, we've got this really fun, I can actually show you for a second, really fun spreadsheet where everyone's actively updating where things are at. That allows me to see how things are going in the breakout rooms. There's an SOS just in case things go wrong. All right. Anyway, welcome, and I'm glad that you were able to meet some peers. In a normal semester, we would be in a giant classroom, and I actually think this is going to allow you to meet people more interesting to you personally than we could have done sitting amongst strangers in a big lecture hall. All right, so we're going to come back to this after just a few quick lessons on how we can compare values and some relational operators. Before I jump into this, there was one question on Poll Everywhere that came up, and that was for the lessons that we did, the responses to the last Gradescope assignment that were on the previous lessons. Would you need to know how to do that without using a terminal? And no, we meant for that to be interactive. We meant for you to be able to rely on that, and wanted you to just continue exploring some of those concepts, right? Vocabulary is worth getting comfortable with is another question that came up. Should you be studying vocabulary? Yes, I think vocabulary is going to be important. And if you want to make Quizlets or flashcards or things like that, it's encouraged. The reason is you're going to hear me and the TAs and in the assignments that we do use technically precise vocabulary. So when we say things like expressions or evaluations or ints, floats, stirs, bools, like these are things that you're going to see throughout the semester. And there's going to be more terminology as well. Like today we're looking at relational operators, which are you're going to know as like greater than, less than, equal to, things like that. All right. I think those are the questions that we have so far. I'll come back to questions in just a bit, but let's get into today's focus. So today we're going to look at Boolean values, which we've kind of glossed over so far. Boolean values are true and false values. Before we get to Booleans, let's talk about equality and relational operators, because this sort of motivates some of their use and why it's important to have Booleans in our languages so that we can make comparisons between two things. And soon we'll learn how to write programs that behave differently depending on comparisons, right? But before we get there, let's start by looking at equality and relational operators. How do we compare two values and determine whether they're equal to one another, or maybe one comes before the other, such as if we were comparing two numbers and wanted to see greater than or less than, or if we wanted to compare two strings, if we wanted to sort things alphabetically, being able to compare two strings to know which string should come before the other, it will be important. So how do we compare numerical and string data with these relational operators? There are a few differences that you'll notice right off the bat based on your experience with these operators in a mathematical context. We use different symbols because the mathematical symbols tend to be pretty difficult to type. You have to use special keyboard strokes in order to get the less than equal to symbol you're used to in math, right? So what you're going to see is this symbol greater than or equal to, or we think of that as is one value at least equal to, or is it equal to or greater than some other value. We're going to write those two symbols one after the other, greater than, equal. And we read this as greater than or equal to when you see this symbol in your programs. The order is important here. You can't flip these two symbols around and say equal, greater. The operator is a greater than symbol followed by an equal symbol. There's a less than operator, there's an at most or a less than or equal to. And then we'll see that there's two equality operators, equal to and not equal to. The double equal symbol and the exclamation point and the equal symbol, right? Let's just, for demonstration purposes, I'm going to open up a terminal in VS Code. And if you want to follow along with opening up a terminal in VS Code, that'd be great. And I'm going to open up a new Python terminal here, or Python interactive programming session, a REPL. And I'm going to make my text a little bit bigger so that hopefully you can see it on YouTube just fine. And we can compare things like 1 greater than or equal to 1 is true because these are equal to one another, right? 1 is 1 equal to 1. True. And so notice that these relational operators, these equality operators, are resulting in a true, or if we said is 1 equal to 2, or a false value. So we're making, we're testing whether or not this expression is true or false. So when this expression evaluates, the computer is trying to determine, is this expression true or is it false? And those are the only two options available to us when we're working with a Boolean type. So if we were to use that type function to see, well, what is the type of 1 equal to 2? Like, what is the type of this expression? We can see that its class is bool, short for Boolean, which is the name. George Boole was the person who invented Boolean logic and Boolean algebra. And it's all about the logic of true false values. And we'll see some more operators that are Boolean specific soon. It's a funny name. I wish, I kind of think a logical or true false is really what you should focus on. But Boolean is pervasive throughout programming languages. You'll see this word all over the place if you try and learn a different language. And the Boolean data type is fundamentally important to computer science because it actually boils all the way back down to zeros and ones, right? Where we tend to think of 0 as false and 1 as true. All right, so let's talk about equal to first. So equal to is two symbols, equal symbols back to back. And you want to read this as is equal to. So is x equal to y if we had x and y on two sides of the equality operator. When these evaluate, as I've mentioned, they result in either true or false. There's no in between here. This is an expression that will return or result in a Boolean value. So it's either going to be true or false. In the next lesson, after we get through these two synchronous lessons, you're going to learn about variable assignment, but you actually have read a little bit about this already. The single equal symbol is for assignment and for variable assignment, and to say, hey, this variable x is going to be assigned to some value that we want it to be bound to. Whereas the double equal symbol is testing for equality, right? We're asking, are these two things equal to one another, true or false? So they're very different, and you want to be very careful not to confuse these two. In fact, you can use them together. So if we wanted to set up a variable named b that was initially assigned the result of testing whether x was equal to y, we could write a somewhat confusing and cryptic looking little line of code that looks like this to make that assignment, right? So this is assigning is b, or b will be assigned the result of evaluating x to y. I could give a quick demo of that. So we could say, b, which will be of type Boolean, if we wanted to declare our type here and say specifically b is going to be a variable that can hold a Boolean type, is going to be the result of comparing 1 equal to 1, right? And so then if we asked, hey b, with a variable access expression, what is your value? What value are you bound to? Notice that b is bound to true, right? So you can use both of these operators in the same line of code. Just be careful because they mean very different things. The double equal symbol is how you compare two values and ask, are they equal to one another? And when would you want to do this? Well, pretty soon we'll be writing programs that ask the user for some input. And maybe you want to test whether or not what they gave you was equal to true. Right? So we could say, or was whether what they gave you was equal to something you were looking for. So maybe the user response is a string value, and they responded yes for continue, right? And so later in our code, we might want to test, did they actually give us yes as an input? We could write something like response equal to the string yes, and that would be true, or is response equal to the string no, and that's going to be false, right? And so we'll learn very quickly over the next week, how do we write code that behaves differently depending on these types of conditions. If something's true, we'll do one thing. If something's false, we'll do another. And these operators, equal to, not equal to, and the others are going to be important for making those types of decisions in our programs. Not equal to is very similar to equal to. In fact, it's just the opposite of it, right? So rather than two equal symbols, it's the exclamation point followed by a single equal symbol. And it has the inverse effect, right? I don't want to over-explain this one. You all are sharp. This one will return the opposite of what the equal to operator returns or resulted in. Right? Each of these expressions is resulting in a value of type bool. And so bool is our logical type when programming. It's short for Boolean. And in Python, the two Boolean values that are possible are capital T true and capital F false. In the next lesson, we're going to look at three operators for comparing and working with bools in conjunction with one another. So is one bool true and another bool true? We can flip whether a bool is true or false with the not operator. We'll look at those in full depth in just a moment. Each of these relational operators is going to evaluate to a Boolean value, right? So it doesn't matter if we're comparing two numbers, if we're comparing two strings, if we're comparing two integers or floats, or two objects of other kinds. The comparison will be of between two objects of the same type, and then the resulting value is going to be a Boolean value. So it's only going to be one case or another, right? And so when we're trying to be careful about the types that we use in our programs and being sure that you don't want to really compare whether a string is equal to an int, that's never going to be true without converting one to the other. So in our programs, we expect that on both sides of any of these operators, we're using objects of the same type. So you can compare a number with a number, a string with a string, and so on. All right. But it's kind of neat because here we're seeing that there's actually a conversion of types in some ways, right? We're starting with two int values or two float values or two string values. We compare them and now we have a Boolean value. That's different from when we added two values of the same type, right? When you add an int with an int, you got an int back. With these operators, precedence is important when you're looking at an expression and it's complex, like this one. 1 plus 1 equal to 2 is how we would read that. And the reason why we can read it in that way is because the precedence of these equality and relational operators is lower than the arithmetic operators like plus and subtraction and multiplication, right? And so if it weren't the case, then this would be like 1 plus true, 1 plus false, right? And that wouldn't make any sense. But because the precedence of the double equal symbol is lower than our arithmetic operators, this is the same as saying 2 is equal to 2. That would be the next evaluation step, and then that would ultimately evaluate to true. So those are equality and relational operators. These are going to be important when we start being able to make decisions in our program. So you can imagine a program that checks whether or not someone, whether their age is 21 or over. You're making a program for an alcoholic beverages company, and you need to check the age of someone using your program. And you would have a condition that says, hey, if someone is 21 and up, we'll show you some content. If not, we'll send you to Disney.com, right? And so being able to make those types of checks is going to be dependent on using these operators to be able to compare two values to make those kinds of decisions. Right? I'm going to pause here for just a second and look and see if there's any other questions. Not seeing any new questions popping up. So I'm going to jump right into a related subject, which is logical operators, and then we're going to go to one more set of exercises and synchronous activities. All right, so stay tuned on Zoom. Very closely related to what we just talked about, because we're thinking in terms of Booleans, is this idea of logical operators. We've seen now how we can compare two things and test whether, say, one thing is equal to another. Well, how can we form more complex logical expressions? And let me give you some examples here. So one, how could we write in our program a condition that looks something like, if there is a pandemic and I am in public? That's two Boolean relationships, right? Is there a pandemic? That's going to be true or false. And are you in public? That's going to be true or false. And what we're saying here is if both of those things are true, we want this statement to that and to also be true. Then you'll wear a mask, right? If it is raining or it is cold, then you might want to grab a jacket. So if it's raining, that's going to be a true or a false type Boolean value that we can figure out. If it's cold outside, that's also going to be true or false to a degree. And we're going to simplify it. We're going to say it's only true or false. There's no in between there. And we're saying if either or both of these things, right? If it's raining and it's cold, then you probably want your jacket, right? But we're okay with only one of these two things being true, all right? And then lastly, if it is not a Comp 110 assignment, then I will procrastinate. So notice we can flip the logical assertions here and say, if something is not a Comp 110 assignment, then I will procrastinate. But if it is a Comp 110 assignment, then you will not procrastinate, right? And so we're going to look at how do we form expressions like this using Boolean operators in the form of logical operators. One of the nice things about Python is that it chooses to use words for these rather than symbols. In other programming languages, they often use like the ampersand twice for the and operator, but in Python, you're going to use the word and to mean and, right? It doesn't get much easier than that. And on either side of the and, you're going to have a Boolean expression. This Boolean expression could be a relationship such as is A greater than B and B greater than C, those types of things, right? So we'll have two Boolean expressions and then they'll be conjoined with and. And the way that you figure out, well, what is the result of and is we can set up a truth table, just like those that you used to learn multiplication tables in elementary school, but truth tables, when we're talking about these fundamental logical operators, are even simpler, right? So if we imagine we've got a variable such as A is going to be this side and A is either true or false, and another variable B, which is also going to be true or false, then if A is true and B is true, like we bring our fingers together on this table and we intersect at true, that's how we result, or that's how the and expression will result in a true value, all right? Similarly, if either of them are false or both of them are false, you can kind of get the point that if you traced your fingers together, you're going to get a false value. And so you can play with this in your terminal as well. So I'm going to quit out of my Python for just a second and clear my screen so that this shows up a little bit closer to the top. Clear my annotations here. So we can play with this. True and true is true, but true and false is false. Now, if all we could do was compare two Booleans like this wouldn't be actually interesting, right? But if we set up a variable like age is going to be an int variable that's 21, we could make it an expression such as age greater than or equal to 21. Notice that's true. Well, we can combine this with some other Boolean expression like and true. Again, this is not too exciting, but we could do and 100 equal to 100, right? Or 1000. And so that was false because the second term of that was false. But if we made the second term here 100 equal to 100 true, we get true out of this. Typically, you would have another condition there. So we can start to form Boolean expressions. Like if the age is greater than or equal to 21 and it's a Thursday night, which it's about to be, maybe you'll take some different action than if it were some other night, right? The point of and is we can join two Boolean expressions together and test whether both of them are true. And that's the only way you'll get a truthful value out of the and operator. Or works a bit differently. And I think the easiest way to understand how these operators work is to look at their truth table. So notice here, if either Boolean expression is going to be true, then the entire expression for that or will be true. So we're only looking for one or the other or both to be true. This is a little bit different than sometimes how we think about or, right? If in English we were to think about like a statement like you can have this or that, but only one of them, that's a different idea that is called exclusive or, and we're not going to be too focused on that because there's not an XOR operator built directly in, and that tends to be less useful in practice for the types of programs that we'll be writing than just having the or operator available. If you really wanted an exclusive or, you can form a complex Boolean expression to make that type of a statement yourself. So or is useful when you want one thing to be true or another thing to be true or either of them and for your expression to ultimately be true. Again, this is another keyword that you can play with like true or false or true. And you notice that both of those are resulting in truthful values. And again, this is an expression and each side of this expression is another Boolean expression. So based on what we know about expressions, you can substitute anything else that's a Boolean expression here and the or operator will still be valid. Same with the right-hand side of it, right? So this is how we're going to start to form more complex logical statements in our programs. Lastly, not is a pretty straightforward operator. It flips the truthiness of some Boolean. So if you say not some Boolean expression, you're going to get back the opposite of what it should have been, right? And so not true is false and not false is true. All right, this one's hopefully pretty self-explanatory. This is useful when you have a complex statement and you want to get the opposite of it for some reason. And you care more about the negation of that. We'll learn some rules for how you can rewrite Boolean expressions to clean them up and simplify them in due time. Right? So what we're going to do next is take this hopefully somewhat intuitive, because these are relationships that you've learned before with the new addition of some of these Boolean operators. I want to try giving you a chance to work through some problems. I want you to try opening up Gradescope, and we're about to go to a Zoom for challenge questions. All right, so on Zoom, we're going to break into small groups again, and there are 2 challenge questions related to these Boolean expressions that we're about to start working through together. All right, and you'll be able to collaborate with your group on this, but I want to give you a minute to think about these on your own before we go to breakouts. All right, so the first question is, what values of A, B, and C, assume that we could plug any values into A, B, and C, and here, think of either true or false values, would cause the following expression to evaluate to true. And notice we've got a pretty gnarly looking Boolean expression here with and operator, or operator. We're using some parentheses to group these things. I would encourage trying to write this down on paper and trying to imagine, okay, if A is true, B is true, and C is true, would this be true? And try and reason your way, maybe backwards, through what you could do to make this ultimately a truthful expression. For the second one, we're doing something very similar, but this time around, notice we're using relational operators and we're comparing values here. So you can compare, you'll come up with values for A, C, and B as well. And some of those might be numbers, some of those might be Booleans, and try and think of what values for that question would you expect to be able to use in order for this to be true. So go ahead and open up Gradescope. There are 2 challenge questions on this, and then a few for the asynchronous material that we'll go to afterwards. But these are our only focus for this breakout. I want to give you a minute to think about this, and then the TAs are going to turn it over to breakout rooms where you can introduce yourselves to each other one more time, and then try and talk through how you approached these problems and what you think a valid solution might be. All right, so these are 2 complex Boolean expressions, and let's try working through them together. As folks are rejoining from the breakout rooms, I'll just say one more thing in response to a couple of questions that came up. So one question that came up was about submissions for the assignment due earlier today. If you need to turn that in a little bit late, that's totally fine. As long as it's open on Gradescope, you can submit. And for this week's assignments, don't worry about late penalties. All right, so let's talk through this first one. So this first one is a complex Boolean expression. And another great question that came up in Poll Everywhere is, I still am not firm on the idea of what a Boolean is, or what is a bool. So if we think about an int as a data type that can represent numbers like 0 or -1 or 1, a Boolean is just something that is a value that's either true or false. So these are the only 2 options for a Boolean. A Boolean is a type that can only be true or false. And so we make logical assertions using Boolean values, and we evaluate Boolean or logical expressions, and they will simplify down to either true or false. Like either 1 is greater than 0 or it's not, or either 1 is greater than some variable, which might be 0, it might be 10, or it's not. There's only 2 options that are valid. So here we're looking at 3 variables, A, B, and C. And when you see an expression that's complex like this, and I should say that this is a challenge question because you really shouldn't write a Boolean expression that looks like this. This is a little bit more complex than you would expect. There's a lot of nesting happening here. So it helps to just highlight where are my parentheses. So we've got 2 sets of matching parentheses that combine the outermost expressions here. So and is joining these 2 bigger expressions. And then we see there's some inner parentheses here, A and B, and then A or B here. All right, and then we've got some others operators. So if this is an and we ultimately want this and to result in a true value, right? That's the outermost and that needs to be evaluated. So both sides need to be true. So we can ask ourselves, well, how can we convince ourselves that this side is going to be true? Well, we've got this or C. So maybe C is going to be true, or maybe A and B is going to be true. We don't really know what to do, how to handle that yet. We could guess a few things, we could guess and check, but maybe if we turn our attention to the other expression, we'll have more of a hint. So here we see another and operator. Ands tend to be a little bit easier to reason about because you know if you want to get a true value out of this, both sides must be true. So if both sides of this must be true, then not C must be true. So if not C is true, then C must need to be false, right? So C is going to have to be false here. And the reason for that is we need this term to be true, and not false would be true. All right, so this would be true. And that would mean that this C is going to be false. And that tells us something a little bit more here. All right, so if this C is false, then we don't know yet, A or B on this side. It could go either way. Let's turn our eyes back towards this first complex expression. And so here it's A and B or false. Well, for an or statement to be true, we know that at least one of the 2 sides must be true. And here, if this side where C was is false, then we're not going to be able to get a true value out of that. So we need to reason through A and B. So this expression must ultimately be true, right? So for A and B to be true, that means both A and B must also be true, right? So for an AND operator to result in a true value, that must be true, right? So A and B are going to be true as well. Okay. And so now if we were to plug these in, true and true or false, this would ultimately, true and true is true. True or false is going to be true. So now we've got true and then on this side, A or B, well, both of these were true, right? So when both sides of an or are true, that results in a true value. And then true and true is also going to be true. True and true is true. And then finally, we get this fully simplified, right? This is mostly in a quick exercise in how to apply these operators and how to sort of reason through them. This is a puzzle in trying to figure out what values could result in a true value, mostly trying to stress and start to get comfortable thinking in terms of and versus or. All right. So I'm going to jump to the next question and then have a few instructions for what to do next. All right. So in this next question, we've got some relational operators. And when we see statements like greater than, less than, and then also another less than there, you tend to want to think in terms of inequalities and the number lines that you're used to from middle school, high school days, right? And so we're going to need a number line here. And if we wanted to, these are both and statements. So ultimately we can think about this one for a second. And we see it's another and not B. So B, if not B, is going to be true because we need this and to have a true value on the right-hand side for it to be true. Then B must be false, right? So we already know what B is. So B is going to be false, right? And now we just need to figure out, well, what are A and C? The technique I like to use in thinking through these inequalities is one that you've learned in earlier in your grade, your math career. So if we say like 9, and then 10, and then 11, and then 12, we can rely on our open circle in line representation of some of these inequalities. So if A is going to be greater than 9, that means A, right? If I use yellow for A, is not going to be inclusive of 9. A can't be equal to 9, or that would be false. And it's going to go in this direction, right? So off in this direction. And for A is less than C, we'll come back to that. We don't yet know anything that's going to bound C. So let's think about C for a second. And we switch our eyes to C. C must be less than 12. So if 12 is here and C is headed in this direction, right? So that's C. And now if we want to apply this particular constraint, we're saying, okay, A must be less than C. So if we pick a value for C like 11, so maybe C is 11, and for A we could pick a value such as 10, A is 10, we could test whether or not this is true, right? So is 10 greater than 9? That's true. Is A, which is 10, less than C, which is 11? That's true. Is C, which is 11, less than 12? That's true. And not false is not false. It's also going to be true, right? And so ultimately, if we used and to simplify all of these down, we would see that this results in a true value. We're going to see when we're writing conditions that operate on ranges of values, using number lines winds up being very useful, right? If you have any questions about these exercises that we did in class, I think the best way to get into further discussion on them is to come see us in office hours tonight. We'll be back open at 7 p.m. Right, let me look at the questions before we close out with a few instructions on what to do on the asynchronous part of today's lecture. Right? There's a question of, can you use Visual Studio on quizzes? And yes, the quizzes will effectively be open to Visual Studio, and there will be coding involved with them, so you will be able to use Visual Studio. There's another question about how how to define and declare and initialize variables, that's going to be answered in the next video. So let me actually talk about that. And someone asked, how should you respond on Poll Everywhere to these questions that we just moved through? Any format is fine. We're just checking for participation. We're not checking for correctness on these challenge questions. So any format will be fine. So there's one more video for today, and it's perhaps the most important topic of today, and that's why I made a video, so that it would be easier for you to go back and watch later as you need it. And that's on variables, right? So the last video here, and there are a few questions to work through, can be found on the website. So let me pull that up really quickly. Under variables, all right? So, oh,